So today I'm going to review the new firmware for the Siglent SVA1015 Spectrum Network Analyzer. And specifically, I'm going to go over how the new firmware affects the Network Analyzer option. Anyway, previously I released a review of the Network Analyzer option. Siglent liked my review and asked me to help beta test the new firmware. They've placed no restrictions on what I can say. Siglent's new firmware has added many highly useful new capabilities to the unit. It includes improvements to the Spectrum Analyzer mode. I'll go over those in a future video. Additional digital modulation analysis types, including quadrature amplitude modulation. Again, I'll talk about these in a future video. And many key improvements to the VNA mode, which I am going to review here. Siglent is scheduled to release the new firmware today, and like all firmware, there's room for improvement, but what they have is excellent and they want to get it to their users. And unlike some manufacturers, Siglent releases the firmware updates free of charge. It shows me they value the user experience of their customers. To me, the best new features of the new firmware are, first, the port extensions. The S11 extension allows you to move the measurement plane to the point you need to characterize and makes the Smith chart a useful tool. The S22 extension allows for adjusting length differences between your through cal and the device under test. This allows you to correctly display changes in phase that you'd get in the unit so there's multiple simultaneously plot types now. Before, you could only plot one thing at a time. You can plot both S11 and S21 simultaneously. You can simultaneously plot Smith charts and or parameters and Cartesian charts. Magnitude and phase can be displayed together, and you can have linked or independent markers on each of the plots. Additional calibration types have been added. These will be the subject of a future video. There's the ability to add notations text to the screen now. There's an on-screen keyboard and the ability to use an external USB keyboard for both file names and annotations. And they've added a read-only FTP server to ease the transfer of data and screen captures. Anyway, one of the primary reasons I bought the Network Analyzer option was because I wanted to use the Network Analyzer to characterize components I have or may buy at RF frequencies. These Chinese SMAs now are very inexpensive, 18 to 25 cents each when you buy them in 100 quantities. Essentially makes them cheap enough to be disposable fixtures. So this is using the reflection method to measure the components. There's also shunt and series methods. In the future, I plan to make details about all various component measurement methods. Anyway, without the port extensions, after you do the calibration plane is about here. It's not where you want it to be. You want it to be right at the component. So the reference plane needs to be here to measure the component. The addition of the port extensions to the firmware release makes the Smith chart now a highly useful tool. So let's look at an example. Here I've got a ferrite bead connected to the SMA through some very fat wire. There'll be a little bit of stray capacitance between these leads, but it's probably in the high tens of femtofarads, maybe 100 femtofarads, but certainly not in the picofarads. And you can see here without the port extension, it's showing that this bead just goes right through the real axis and becomes capacitive. That's not what happens with ferrite beads. Now, if we add the port extension, we can see here that the bead quickly goes into a region where it's primarily resistive with a little bit of residual inductance, which is the way a ferrite bead works. So you can see here I have 3 markers. Here's the real part of the impedance, the imaginary part of the impedance, and the effective inductance of the imaginary part of the impedance at where each of the markers are. So let's take a look at the effect of the port extension. Here it's on, here it's off. On, off. So you notice the lines moving. The purple is the phase of S11. The blue is the magnitude of S11. You notice the magnitude does not move as I change the port extensions. It's just changing the phase. It's actually adding a time delay or gain, depending on whether you make it positive or negative, which will change the phase versus frequency. That's what a port extension is. Now, if we look more at this plot, we can see here now that trace 1 is, of the 3 traces on the screen, is the one that's selected. That means that the markers being displayed will be for trace 1, even though there's markers on trace 2 and trace 3. You can this shows that the calibration correction is on, and P shows that I have the port extensions turned on. You'll notice here where the markers are. The bottom corner of the markers denotes where the marker is. This is the same as it is in the spectrum analyzer mode, so this bottom corner is the point that that's being marked. Now let's look at a bandpass filter example. Here I have both simultaneous S11 and S21 plots. The yellow is the magnitude of S21, and all the plots in this particular screen are averaged to the maximum of 999 averages. And with that averaging, I'm getting essentially over 100 dB of dynamic range for the magnitude of S21. The purple is the phase of S21. Blue is the return loss, or the magnitude of S11. And the fact that I'm getting a minus 50 dB peak, it's really a valley, shows the excellent directivity of the input port coupler. And then the S21 group delay is this green line. Now when you turn on averaging, you turn on averaging on or off. You can turn it on or off for each one of these traces. So I could have, let's say, the averaging on for this and not for the others, or I could turn the averaging on only for the group delay and have it off for anything else. But it takes just as long to average one trace as all the traces, because it has to go through the, that many sweeps to do it. You might as well just turn it on for everything. Now, one of the things it does is it averages each trace after it's done. So the group delay is calculated from the magnitude of S21 and the phase of S21. And then that calculation is averaged. The problem is when you get away from the bandpass portion out here, both the magnitude and phase of S21 are noisy, so you're calculating the value from noisy data and then averaging it after you do the calculations. I suspect it would be much cleaner if the calculated values like group delay were done with average data, calculated from average data instead of being averaged after they were calculated. So now here's the same data again, but I've changed the group delay plot, essentially trace 4, and turned it into a Smith chart. So both the Smith chart, trace 4, the green, and the blue trace are plotting the input data, and the input impedance or return loss. And then the yellow and the purple are plotting the S21 magnitude and phase. And I can see all these simultaneously. It's kind of a busy plot and hard to look at, but while you're doing it and checking things out, it's very nice to be able to see all these at the same time. I'd probably simplify them for a formal presentation, but it's very nice to be able to see all these at once. Anyway, when you're plotting, to me, it seems when you're plotting both S11 and S21 data, it does one sweep for each. It'll do a sweep for S11, then a sweep for S21, a sweep for S11 and S21. So it seems to interleave the sweeps. Now let's look at this. This is the same filter. I have all the averaging turned off, and you can see now the noise in the magnitude and phase data that's causing the noise in the previous noise in the group delay. But see here, I have three traces, trace 1, trace 2, trace 3. Right now trace 1 is selected. When trace 1 is selected, the scale on the left-hand side is for trace 1. And you can see now that magnitude's 0 dBm up here, 0 dB up here, minus 100 dB at the bottom with 10 dB per division. If I go to trace 2, which is the phase, that's 36 degrees per division. But again, it's plus 180 at the top, minus 180 at the bottom, 0 in the middle. Now if I select the third trace, you can see here that now this is the magnitude of the return loss, or S11, so it's 0 dB at the top, minus 50 dB at the bottom, 5 dB per division. So you can see it's the same data, each time. But it's sweeping, so you can see the noisy portions are changing with each sweep. Now the firmware's also added an anonymous read-only FTP server, which I really quite like. It allows me to transfer the data to my system without lugging a thumb drive back and forth. So, you can use it with a web browser as shown here, where you put the IP address you've assigned the network analyzer in a web browser, although I prefer to use an FTP client so I can transfer all the data stored at once. Once the data's been transferred to my computer, you can go to the network analyzer, and in the file menu there's a select all function and then a delete option that will delete all the files you've just transferred and clear out the memory. So let's quickly try and go through some of the features of the new firmware for the network analyzer. If you select measure, you get this basic screen here. This is the top screen. Stimulus allows you to, is basically the same thing as the frequency key, but it also is where you can change the number of points. Right now I'm at 201, which is the default. 751 is the maximum. If we go back, this selects for the current trace what's being displayed. So if we look right now, let's go to trace and let's select trace 1 or trace 2. Okay, let's go back to trace 4. So right now trace 4 is also displaying the Smith chart, the same thing as trace 1. Now trace 4 is active, so if I come back here to measure, if I select S21, it will now display S21, and which doesn't do anything because I'm not hooked up, so let's go back, S11. But I can change the format here and put SWR, measure amplitude auto scale. That's kind of silly. Okay, so that's the SWR scale for S11. Anyway, if we go back here to trace, we can go to 3 traces and turn that one off. Come back here. Come back to measure. If we go to scale, that adjusts the scale units for the current trace. So if we go to 2, measure, scale, so that's very similar to the amplitude key. In fact, it's identical. Measure. Calibration. Now this is where we find lots of interesting new stuff. Here's where you can turn the calibration on and off. So here, this is uncalibrated. This is calibrated. If we go to the calibrate screen, this is where I can do the 1-port or 2-port calibrations. Ecal, that's probably for, my guess is that's for Hewlett-Packard automatic cal kit. Not useful to me, but somebody may find it useful. So this is the Siglent cal kit. Here's a couple of Hewlett-Packard cal kits, and now you have the choice of male or female. And here are user cal kits in which you can input the delay for the open, short, and through. I haven't experimented with these yet, so I don't know how well they're working, but that's where you find them. And here is the velocity factor for the port extensions. The velocity factor is essentially how fast is the proportion of the speed of light that signals travel down a wire. And 66% of the speed of light's fairly standard for coax, so that's what it's showing here. So if you turn on the port extensions, here you can see here that you can, there's port extensions for 1 or 2, and it shows both in picoseconds and length, assuming that the velocity factor on the previous stage. You can turn them on and off here. You can watch the lines shift as I change. So these other lines aren't shifting quickly because I have averaging on. So let's go back to trace, and I can turn averaging off on trace 2, turn averaging off on trace 3. And so you notice here that as I select each trace, the averaging is turned on and off for each trace. So if I come back here to measure, calibration, port extensions, now if I turn the port extensions on and off, you can see that the phase and the Smith chart are shifting, but the magnitude is not. Now on the screen there's always this little dooley bob down here. I don't know what it is, but you can touch it and you can always take a screenshot. Now here, if you touch this now, you now get an on-screen keyboard, which is very nice, because before all you had was this funky keypad to enter things. This is much easier, but I find it even easier to use an external keyboard. Now here I can do Control A, selects all. The arrow keys work. So here, let's say here I could call this ferrite bead. Control A. Control C will copy. Control V will paste. Control U, which is the Unix clear the line before the cursor, does not work. But none of those are available on this keyboard. So now here I can hear enter, and now it's saved an image of the screen. Now I've set the default file type for the save key to be CSV, and here now I can do Control A, select all, Control V, paste, and now I have the same file name there that I had for my image file. Can save that, and that will now save the data. Now, interestingly enough, now that it will save the data in 3 different chunks. It will save the data for the S11 Smith chart, which will, if we go to trace and select it, it will save all this data. 2 S11 log magnitude will just save the log magnitude of S11 in phase. So, but now I've gotten all those things saved in one file, at least in different sections, but now just one file, because when you hit a data save, it saves the data for all the traces being displayed. Now there is one kind of gotcha here. If you look at trace, which one is it? Sweep. Okay, sweep also gets you the number of points. This button. Peak. This one's kind of interesting. It doesn't show well here, but let's select trace 2, and we'll take a peek. And it took the highest value there and moved the marker over there. There's no next peak. Peak will just automatically move the marker to the highest value, valley to the lowest value on the trace. Somewhat useful, but not terribly. If we go to the marker screen here, you see we have multiple traces. We can select the markers turn on and off the markers on each trace, and we can couple them so as we move the markers around that they move on all the traces. So right now you can notice I have the one coupled on all 3 traces, and as I move it, it moves back and forth. It's moving on all 3 traces simultaneously. That's a feature I quite like. Go to amplitude. Okay, yeah, so now amplitude, this is kind of interesting here. If we look at, we're on trace 3, reference position is 0 is at the bottom of the screen, 10 is at the top of the screen, and that has nothing to do with reference level. And so here, these show that whatever this third line shows the reference level, but not the reference position. The default reference position's in the center. So it always divides this up to 10 divisions. So let's say if I set this to 5, enter, it's moved the reference level for the phase to the center of the screen now. Right, and so, and now you'll notice here as I go to select these traces, the problem is that it only shows where the reference level is for the current selected trace, and that can be different because of that reference level in the other one. So it would be nice if these little triangles, all the colors showed up in the right spots, no matter what trace you were on. So let's look at the conclusion now. Oops. Sorry. I dropped my mouse. The conclusion. Anyway, the port extensions are probably one of the best features for this, the new firmware. They make the Smith chart a highly useful tool for measuring impedance, and they've also made me a very happy owner, since the unit is now does one of the things I primarily bought it for. The multiple simultaneous plot types allow viewing multiple parameters and saving them as data, and however, the file formats, data stored in the files, and default file names still need improvement. Annotation text makes screen captures much more useful. You can, the image, you can put in there what you're measuring, or put in text that you can use directly in a presentation without replotting it. You can use an external US keyboard for both file names and annotations with the ability to copy and paste, and that makes having useful file names much easier. The read-only FTP server negates the need to use a thumb drive to save and transfer data. I still need to evaluate the additional calibration types. Anyway, Siglent's new firmware improves the performance, adds many new useful capabilities, and enhances the value of the VNA option. I'm now very happy with my SVA1015X. Anyway, if you like this video, please give it a thumbs up. And if you want to see more videos from me, please subscribe. Thank you.